In this video, we'll review how to create a bicycle impact simulation, where the pre-impact portion of the bicycle and rider system is controlled with the path animation tool. The same workflow also applies to motorcycles. Note, a similar workflow is possible with the kinematics tool. We've placed our simulated multi-body on top of our bicycle. Notice, when we start the simulation, the system naturally falls over due to asymmetries in the system's lateral weight distribution. We want to hold the rider's body and bicycle upright. We will use the path animation tool to hold the bicycle upright. We will adjust the multi-body's joint stiffness values to keep it locked in a rider's pose until just before impact with our bullet vehicle. Let's use the path animation tool to keep the bicycle upright. We'll release the bicycle from animation control just before impact to simulate the collision event. Left-click in the scene to lay out the animation path. Adjust the control vertices as needed. Set Evaluate to Forward. This makes animation sequence programming analogous to simulation. Set the distance offset to 0. Remove all of the default sequences. We only need 3 here for our example case. We will first use speed change to give the bicycle a non-zero initial speed. Next, we will use uniform to define a path segment along which the bicycle's speed remains constant. Finally, we'll use off to switch off the animation path control over the bicycle's motion. At that time, the bicycle will be controlled completely by the simulation engine. Let's set the initial position of our simulated bullet vehicle. We set depth of penetration to 0 since we expect little crush on the bullet vehicle's front bumper. With the trajectory set, we'll now fine-tune the bicycle's orientation by switching to interpositions mode. First, we'll start at a distance of 0 along the bicycle's trajectory. The bicycle begins upright, that is with roll equal to 0. Next, we'll place another, roll equals 0, into position just before the bicycle begins to lean. This second position establishes a starting point for the non-zero roll angle the bicycle will take along the turn. Next, we'll place a new into position to set the location of maximum roll angle. Finally, we set the last into position for the turn maneuver, with roll set back to 0 degrees. Now let's position our multibody on the bicycle at its initial position. It's often helpful to use the stop simulation option while doing this so that the bicycle remains stationary. Now, convert the multibody to a rigid body object. This allows us to attach the multibody joint segments to the bicycle using spherical joints. We'll temporarily hide the skin envelope to make it a little easier to work with the multibody. Now, select the spherical joint tool. Hover the mouse cursor over the multibody segment, left-click, drag to hover over the bicycle and release to make an attachment. Let's also attach the pelvis to the seat. Now we see our multibody moving nicely with our bicycle. Our work isn't finished yet. With the use time option, we'll break these attachment joints at the same moment when the bicycle is released from the animation path, just prior to impact. Now, we need to increase joint stiffness while the rider is on the bicycle. This will keep him upright. We'll relax the joint stiffness values just before impact. Select all the joints. In the Fix Orientation menu, enable Use. Next, left-click on the box next to Spring. Select Rectangular Pulse from the drop-down. The diagram tool lets you control the time dependence of various input values. Here, we set offset Y and amplitude to 1000. This will create rigid joints. Set period 1 to the time when the bicycle is released from animation path control. At this time, joint stiffness will be completely relaxed. Note, period 2 is set to 30 to prevent joint stiffness from stepping up in value again during our simulation. If you want a specific joint to persist with some non-zero stiffness after period 1, then simply adjust the amplitude or offset Y as needed to maintain a non-zero value after period 1. We'll do the same for the damping coefficients. This will help diminish unwanted minor oscillations in the multibody segments. Because we see some unwanted movement in the multibody, we'll use the Fix Orientation option for our 3 attachment joints to better hold him in place. To eliminate some unwanted, but slight, movement in the feet, we'll add a joint connecting each foot to its pedal. Let's hide the joints and multibody segments and show the skin envelope. Note, as you further refine your animation path, your rider should remain on the bicycle. If you want a stationary rider pre-impact, simply start your sequences with a reaction or uniform sequence instead of speed change. Enable the use time option, and set the time to the duration you want the bicycle held upright and at rest. Use the off sequence type next. This will release the bicycle from animation path control, and the simulator will take over. Be sure to modify your joint connections and stiffness values as needed for proper timing. Virtual crash. Accident reconstruction software.